Hello. Welcome back to my channel. So I'm going to go over the test review for this final test of the school year, the solutions test. So hopefully I'll make this video like 3 parts, so it's not like a super long video. So this is like part 1 out of how many parts I'm going to do. I don't know. So as I'm going to build this key, I'm going to go over the questions. So this first part of the test review here is the solubility curves. Excuse me. So these questions here so far is basically asking when is it saturated. So what mass of solute will dissolve in 100 milliliters of water at the following temperatures. So for part A, KNO3 at 70 degrees Celsius. So whenever there's the compound, that's the line you're looking at. And so in this case, it's this line over here. And then whenever it only gives you the temperature and the temperature only, you just find the temperature and then you go up to the line. So whenever it says what mass of solute, it basically is asking when is it saturated. And remember, saturated is when it's on the line. So so I find KNO3, I find 7 degrees, go all the way up to the line of KNO3, which is roughly 130 grams. So basically it's saying at this temperature I can add 130 grams of KNO3 in 100 milliliters water to be a saturated solution. So that's how you do that. And then part B, same thing, just NaCl at 100 degrees Celsius. So if I find NaCl is one of the hardest lines to read, so I apologize for that. But you go to the temperature, 100 degrees, go up to the line right here. So it's pretty much 40 grams. Okay, same thing here. So try to do this by yourself. Pause the video and then see if you get it right. Alright, so I got 70 grams because I went to 9 degrees, went up to the line of NH4Cl, and I got 70. Alright, so that is the solubility curve. Oh wait, there's one more question, my bad. So this another way of wording of when is it saturated is if it says what is the solubility. Again, solubility also means saturated. And this time I'm looking for cesium sulfate, so this line that goes down here at 50 degrees. So 50 degrees on the line, that's pretty low, so that's roughly about 5 grams. Okay. Alright, next part. So you have this table here. Use the solubility curve to label the following solutions as saturated or unsaturated. So it's either one of those two. So it's either going to be on the line or under the line. If unsaturated, write how much more solute can be dissolved in the solution. Okay, so since we're doing the second part, I'm going to use a different color. Alright, so a solution that contains 70 grams of NaNO3 at 30 degrees Celsius. And it says 100 mils of water. So the 100 mils of water is important because if you see the other questions, 100 mils, but yeah, so the 100 mils of water just means the standard, that is the y-axis, but that's basically what you'll be tested on. If it says 200 mils or 50 mils, you have to change the ratio of your grams. So that's just as an FYI. So this first part for NaNO3, 70 grams at 30 degrees. So whatever gives you grams and temperature, that's when you literally just pinpoint it on the graph and then compare it to the line. So I'm going to find 30 degrees, 70 grams, that's going to be over here. So when you compare it to the actual line of NaNO3, it is under the line, therefore it is unsaturated. So since it is unsaturated, we have to answer this question. How much more solute can dissolve in the solution? So think of unsaturated meaning like in a Kool-Aid type of analogy, like you put too little sugar like the Kool-Aid mix into your water, so it's very dilute, it's very watery, you can add more of that Kool-Aid to make it more saturated. So that's what it's asking, how much more can I add for it to be saturated. So I start here and I add how much more for me to hit the line, for me to be saturated. So for me to be saturated, it's about 95. So I'm at 70. I can go up to 95. So what's the difference? 25 grams. So I can add 25 more grams of the solute for it to be, you know, not too much, for it to be saturated. So there's that first part. Okay. So this next part, we're looking at ammonium chloride. So 50 grams of that at 50 degrees. So I'm going to find ammonium chloride right here, this line. 50 grams, or 50 degrees, then 50 grams. Oh, that is exactly on the line. So on the line means saturated. And since it's saturated, we don't have to worry about that because we don't need to add any more. Alright, try to do this next part. Pause the video and then play the video once you get it and see if you got the answer right. So I got saturated for this one. Hope we got that right because it got exactly on the line. Alright, this next one, again, try to do it by yourself and then pause the video, see if you get it right. I got unsaturated for this one, so that means you have to count how much more for you to get saturated. So 70 grams all the way up to 130. What is the difference there? You should get 60 grams. Okay, so that's pretty much the solubility curves. You got to know the difference between unsaturated, saturated, supersaturated. So I know there's no supersaturated here, but all that means that, like, let's say I give you the temperature in the grams and I'm looking at NaNO3 and it pinpoints here. Since it's over the line, that makes it supersaturated. Okay, so this next part is the molarity dilutions calculation. So I'm going to go ahead and quickly do those equations so we can reference those. Alright, and since we're going to this next part, I'm going to use a different color. Let's try this one. Okay, so number 2. What volume of 0.5 molar potassium chloride is needed to make 200 mils of 0.1 molar solution? So I'm just going to start off with underlining what I know. And then you ask yourself, okay, I have these two equations, which one do I do? So since I have two m's here, that's automatically my dilutions equation. It is asking what volume do I need to make this new, less concentrated solution. So I'm using dilutions. Let me try to zoom in. That's so much better. Okay. Alright, so I have 0.5 molar and then 0.1 molar. So I have two molarities here. How do I know which one is which? And it does matter because what is the definition of dilution? To dilute something, it means to like water it down. It means to lower concentration. So your final molarity, your M2, should be the lower concentration. So that would be 0.1. So M1 would be 0.5. Your M2 would be your 0.1. And then you have your V1 versus V2. So whenever it says what volume is needed, like how much volume you need to add, that is always V1. So V1 is your unknown. And since your V2 is in milliliters, you can keep it in milliliters. As long as your like units match. Let me try that again. There we go. That's better. You can convert it to liters if you want to, and then your final answer would be in liters, but as long as it stays the same, it doesn't matter to me. Okay, so now that you have everything that you have, you can just plug that in. So M1 is 0.5. Your V1 is your unknown. Your M2, which is 0.1. And then your V2 is your 200. And from there, you algebra. You math it. So what do? You divide by 0.5 on both sides. So when you do that, you get 40 milliliters. So for your test, since it's like multiple choice, if your answer choice is in milliliters, then yeah, your answer should be milliliters. But if it's in liters, then you may have to convert. But I honestly think your test, like, you don't need to convert to liters. I may be wrong, but the only equation that you have to have in liters is the molarity, the mole over liter. That must be in liters, which leads to the next question. Alright, so number 3. What is the molarity of 45 grams of HCl dissolved in 1 liter of solution? So, like I said, you're going to use your molarity equation, and we have to find the M. So the molarity is big M. That's question mark. And then we have the liters. So my liters is literally just 1. But do we have moles, though? We are given grams. So how do we find moles again if we have grams? We've done this before. So mole equals, let me try that out. I'm going to write it right here. So your mole will equal your 45 grams of HCl divided by your molar mass of HCl from the periodic table. So you have to find your mass of H plus your mass of chlorine. You add them together, that's your molar mass. So put that to the side. H is 1.008. Cl is 35.453. Add them together, you get 36.461. So that is what you divide by 45. You should get 1.234 moles. And since it's divided by 1, that's basically it. Your molarity is 1.234 divided by 1, which is just 1.234 molar. That's your final answer. Okay? If it was like 2 liters, obviously you divide by 2 and it would be something else. Okay? So that is how you solve for molarity. And I think there's a couple more in the back side. So let's flip over. Okay, so more molarity, more calculations. Let me just rewrite the equation here. Alright, so number 4. What is the molarity of a solution where 7 moles of HNO3 is dissolved in 300 milliliters of water? Okay, so we're trying to find molarity. Question mark. We have our moles. We have our volume. But, it's in milliliters. We got to convert that to liters. So it's 300 milliliters divided by 1,000 to get your liters. So it's 0.3 liters. Okay, so when you plug this in, it's just 7 divided by 0.3 equals, it's going to be a high concentration, 23.33 molar. Alright. Okay, number 5. How many grams of HNO3 should be added to 5 liters of water to prepare a 0.078 molar solution? So, we are given the M. We are given the volume, the liters. It wants grams. So, according to our equation here, the molarity equation, what can we find first to get to grams? We're missing moles, okay? So, we're going to plug it in, 0.078 equals moles, which is our X value, divided by 5. Remember your algebra, you just multiply by 5 here, so 0.078 times 5 equals your moles, so that should equal 0.39 mole. So if it was asking for moles, you stop here. However, it wants grams, so whenever you want grams, you multiply by the mass of your compound. So if you find the mass of HNO3, go ahead and pause the video and try to find that. Again, you add all the elements together. 1 H, 1 N, 3 O's. When you add them all together, pause the video, see if you can get it. So your molar mass should be 63.012. Make sure you do this right, because again, with the test being multiple choice, and you do them like the mass wrong, and then you obviously don't find your answer in your answer choices, you did something wrong. So you gotta be careful, okay? Especially the 3 O's. A lot of students like forget that. Okay, so now we just do 0.39 moles times 60. Why did I do 39? 63.012. That should equal 24.575 grams of HNO3. That is my final answer. Alright, so last problem. So action number 6 is very similar to, actually, yeah, it's just different numbers. Very similar to number 3. It's asking for molarity, and it's giving you grams, and your volume. So go ahead and try to solve this. This is KCl, not capital L. It should be KCl, like that, potassium chloride. So go ahead and try to solve this by yourself. Pause the video, and then once you get it, play the video, and then check your work. Okay, you should have gotten this as your final answer. First, since you're given grams, you need to find moles. So I divided it by the mass of KCl from the periodic table. So K plus Cl added together, it should be 74.551. When you divide those, you get 1.864, and that is your moles. And then you divide it by your liters, and luckily this is already in liters. So 1.864 divided by 30, which turned out to be a very small number, which is okay. Okay, so now vocabulary. So when it comes to your test, you're not going to be given like a vocabulary quiz or like define this, define this. No, it's like you're going to have questions where you may be like, you see one of these vocabulary words and you have to know what it means. So that's the main goal for this. So I'm just going to talk about each word and then write the matching definition just so you understand what they mean. So the first one, dissociate. When you dissociate something, it kind of, how do I put it into simpler terms? When you dissociate yourself from other things, I guess, like you push yourself away, you break apart from the situation. So same thing with solutions. When solutions dissociate, they break apart. So that would be H. Okay. Now, part 2, or number 2, electrolyte. So electrolyte is when the solution can ionize in water. So think of Gatorade. Gatorade is the famous drink that has electrolytes. So it ionizes in water. So where's that in the thing? C, yeah. So letter C. So an ionic compound that produces ions when dissolved. So a good example of electrolyte is like sodium hydroxide, because it's a strong base, therefore it has strong electrolytes. Non-electrolyte, that is opposite of electrolyte, so that would be a substance that does not ionize in water, so that would be letter G. Solutes. So we all talked about solutes before. It's the thing that you put in a solution to dissolve. So that would be letter B, substance that dissolves in a solution. So salt, sugar, whatever you put to dissolve. And then solvent is the thing that does the dissolving, that dissolves the solute. So that would be J, the dissolving medium of a solution. So it's the thing that holds the solute together. So that would be J. Unsaturated, which we just talked about in the previous page. That would be the solution with less solute of a saturated solution. So like under the line, less than saturated. So that would be F. So let me actually cross out the letters that I already used. F, G, H, B. What else did I? Oh yeah, and J. Yeah, there we go. Okay, dilute. So when you dilute something, you make it thinner or you water it down. So where is that? There it is. I'm blind. Made thinner or weaker by adding water. Adding water is a key word. So E. Okay. Concentrated form. I think concentrated from ions. I think that's what it means. Oops. From ions. Concentrated. So it means it is made denser. It's thicker. So A. Solution. So solution is simply a uniform mixture. That's literally all it is. Saturated. So that is when it is the maximum solute. So down here. So the maximum can hold M. So if you see the pattern now, supersaturated is when it has more solute. Okay. Alright, immiscible versus miscible. So let's see what's left. We've got liquids that mix in all proportions, and there's the liquids that do not mix. So, keyword, immiscible. Im means like opposite or cannot. So, I, the liquids do not mix, that would be immiscible. Liquids that mix in all proportions, that would be miscible. Okay? So these are your vocabulary words. Again, don't think of it as, oh, it's going to be a vocab quiz, it's going to be a vocab test, I got to define stuff. No. You just have to know, excuse me, you just got to know what they mean when you read the questions. So that's an important skill to have, especially for next year when you're reading these vocabulary, like, oh, what does this mean? What is it asking? It's important to know the definitions. Okay? So, I think I will stop here. I think I did a full page. Yes, there's 2 more pages. So this is, So this is part 1 of the test review. So we just basically covered all of solutions, essentially. But yeah, I hope this helped. And I recommend a lot of practice, especially with the curves and the calculations. A lot of that on the test. But other than that, I am pretty much done with this part of the video. If you have any questions, let me know. I hope this helped.